Hi, as you may have heard, DuckDB just released DuckDB UI. This means you can now run DuckDB locally and have the same UI interface that is available in MotherDuck. In this tutorial, we're going to be building this visualization using the DuckDB UI to load data into MotherDuck. The data is coming from a GeoParquet file, which is part of this project called the Emotional Cities project, which has data on factors determining mental and emotional health in cities. And so we're going to be building this visualization using GeoBase and MotherDuck combined. So here's what we're going to be covering in this tutorial. First, we'll run DuckDB UI locally. So we can then import our GeoParquet file into that local table and then log into MotherDuck and put that table into the cloud. Next, we'll connect GeoBase to this table so that we can see it from GeoBase. Next, we'll create a materialized view of that table, ensuring that it includes a geospatial column, allowing us to access it using GeoBase vector tiles. We'll then integrate this table into our UI using the vector tiles and then add an RPC endpoint to fetch the statistics about our data. And then we'll also add another RPC point that is a bit more complex, which will get the statistics based on the bounds of what the user is looking at. Finally, we'll connect all these functions together into the front end and explore the code in the visualization itself. By the end of this tutorial, you'll have a fully integrated geospatial pipeline with GeoParquet files, DuckDB, MotherDuck, and GeoBase. So let's get started. Okay, so the first thing we're going to do is start our DuckDB UI. So I'm here and I am going to look at what version I'm running. And this is a version that does have the UI. So the first thing I'm going to do is install the Spatial extension and load it. So let's run that. After that is run, I'm going to go to the website for the Emotional Cities project and I'm going to find the URL for this particular data set for London, which is a hex grid with prevalence rates of cardiovascular diseases in London. And we're just going to take that data and just query it. And this data is available in a GeoParquet format here. And we're going to try it out. So we're just going to run a query here saying select the geometry from this Parquet file, then limit it to 10. And here's my output. Our data made up of multi-polygons. We want to use it with our data in GeoBase, especially with the vector tiles. Okay, we know that DuckDB does not have support for storing SRID with their geometries. They only store the geometry itself, and that's how it is. You have to store the SRID somewhere else. Let's just store the data as WKT, and we just then have the multi-polygon in our database. I'm going to here create a table with a select star with an exclude, and it just says that I want to include all the columns except for geometry. And then I'm going to take another column we'll call WKT, create a column called WKT, which has my geometry as text. So that's going to create a new table called Cardio 1920. And I want to run that in memory. Let's run that. And now we have this loaded 300 to my table. So I can look at it here with some information here. Now, next thing we're going to do is put this data into my MotherDuck account so I can then access it from the cloud within my GeoBase project. So I'm going to run loading this data, this one, load it inside this IDB. Now notice I'm going to go to my import here. So I'm going to create table, my table name as exclude, and then change this to be on my server and just run that. And now if I go down to my server, I will see this new table. So the cool thing is this interface here is basically the same as going to the DuckDB website. For example, here I can invoke some tokens or do everything as if I was logged into the website on their website, which is really neat. Except this UI is running locally and it can interact with the database locally or it can interact with the database on the cloud. Let's move on to connecting this table within GeoBase. So I'm going to go to my GeoBase Studio and here's my project. I'm going to go to my SQL editor. So first thing we need to do is create a server that connects to my MotherDuck instance. And the easiest way to do that is just to go to the GeoBase templates and look for create DuckDB FTW server and basically run this. This defines a function that says create our server. So if I run this, select this part, I now have a function that's called DuckDB create server. I can just create a server called MotherDuck server. So let me go and get a token that I can use to connect to that. I have to go to my MotherDuck interface, create a token and demo token. And let's say it expires and the next few hours. I'm going to copy that and go to my studio, paste that here, and run this. Okay, so it's saying that the DuckDB server already exists, so we need to delete that. So you can drop that server. So let's go and drop that. So to do that, let's go to the templates, and you'll find here drop the server function. So I'm going to run this function creation step first, and then I'm going to drop the server. So this will delete any tables that I had from that server as well. So that's gone, and now I can go and simply run this again and then that's going to give me a connection. I don't see any tables here yet because we have to now add a table from our MotherDuck. To do that, I just simply go and click on manage function, manage tables. I can select all of this except for the example usage. And that's going to create a new function called DuckDB manage foreign table. And I'm going to say add. It takes an argument, which is a command, the action, the name of the server, and the table you want to add. So in my case, the table I want to add is called X350 grids cardio, which we have seen here, this one. So let's go back and run this. Now, if I go to my tables, I should see a new table here with all the data coming in from the Duck. So here, this table is actually got that new column that I added with the polygon information. So next thing I'll do is create a materialized view, and that materialized view is going to be connecting to this table, but also add a geometry. So let's do that. So here I've done this before. I'm just going to copy this for now, which is I'm going to create a view, and in that view, I'm going to take okay, so it's a little confusing, but this is easy. I'm just selecting all the columns that I want and just renaming them because the names in the inside of the Duck or the Parquet file had uppercase. I don't like my columns being named with uppercases. And then I'm going to take the WKT and I'm going to create a geometry from it. And off the type, multi-polygon, and I'll call the function stGeometryN and take the first one. Because it's a regular polygon, I don't need it to be a multi-polygon, so we might as well convert it to a polygon. And then I coerce it here and tell it the types. Otherwise, the tile server won't be able to see it. I don't actually have to do this, but I do it anyway. And then after that, I'm going to create an index on the geometry columns. That's always a good practice. And I'm going to run this. Whoa. So that tells us that we actually have a new Geospatial table. So let's run this, which is going to add our geometry, and then we can go to our tile server. And here you'll see a new column, and we can actually start building with this. We can select this and open it in code editor and see the actual data or see the actual geospatial geometries. That's not the only thing. We now have to start integrating this in our front end. And the way we'll do that is open up our front end code. So if I go to my pen and look at this, you'll notice here I've already got this working because it's taking advantage of this column. And because of the code here is already taking those values in the column and then just converting them into these three-dimensional views. And so let's just quickly go over this. So I have my API keys here, and essentially I need to have my GeoBase client here, which I have here. And then I go to my JavaScript, and here I say create GeoBase client, which takes my URL and API key and creates a GeoBase client. Now we're going to use this client variable to do a few things, but the most important thing is the tile server. So if I go to tiles, source here I'm adding my source. So here's my project ID, and then my API T1 settings here, project settings. I can get my project reference here. So let's quickly go over this code. One of the core features we are using here is the GeoBase API to fetch tiles and show that data on our map. And we can see here the UI has the ability to see the different types of variables and show the difference between the average value versus the higher and the lower than the average value. So the reds here mean it's higher than average cardiovascular disease, and then the blue means it's lower than the average prevalence of the cardiovascular disease, and the whites and the grays are close to the average. Similarly, we have here the statistics for the actual values, and we can see the results down in the bottom here as we hover over the map. We also have the ability to switch between the 2D and the 3D view. And then we have this current view versus the global view. If I switch to current view, it's going to show me the difference between what I'm looking at versus what the global view is. Right now I'm looking at everything, so there's no difference. But if I zoom in, you will see this chart update. Let's make this a little bit bigger so it's a bit more understandable. So that you can see here that here we're seeing the data we're seeing has different averages and min-max compared to the global. As we zoom around, we can start to see the differences update. So let's just quickly go over the code here. First thing we do is set up our connection to GeoBase, and then we are setting up some initial values, followed by some functions that are going to be handling all the statistics for the visualization and fetching the data. So the statistics part is here we're writing some functions that will fetch the data using this RPC call to get the prevalence statistics, and then getting the min-max values and displaying those for this chart. Similarly, we have a function to switch between our global state and functions to fetch the bounding box that we're looking at. And then a lot of the code is devoted to the visualization. So you will see in the end here, setting up all the map layers and the state management of that. So interactive mapping is here. And we can see here as the map loads, we set up all our initial state. So that's a very high level overview of the code. We will do a deep dive at some point, but you can see the access to the code in the YouTube video. And I should mention that this project is part of the Horizon 2020 research grant and innovation program funded by the European Union and part of the Emotional Cities project. The project's goals are to look at the non-quantifiable information on the wellness of people living in cities based on some of the proxy variables of health, disease, happiness, and so on.